Hi everyone, my name is Rohan Fernando, and today I'm excited to walk you through my portfolio optimizer, a tool designed to bridge the gap between the retail stock picking and professional grade asset allocation. Before we begin, I'd like to provide my AI usage disclosure. I collaborated with AI to architect the React frontend and verify the matrix mathematics within the optimization engine. All financial logic, parameter tuning, and the driver methodology were directed and validated by me to ensure academic and professional integrity. My current portfolio consists of nine diverse assets. As you can see here, I can add a couple more. For example, let me add Netflix. There's Apple, there's Microsoft, there's Google, there's Amazon, Tesla, TSMC, Netflix. This application retrieves 250 trading days of historical data for each, as you can see right here. One of the primary challenges I addressed was building an interface that could handle varying volatility profiles from the stability of Microsoft to the high end growth swings of Tesla, for example. There's three objectives that you can choose from. And first, there's a max Sharpe ratio, which is the highest risk adjusted return. Then the minimum variance, absolute minimum portfolio volatility, and the risk parity, or the approximate equal risk contribution. In this demo, I'm prioritizing the max Sharpe ratio. I chose this because in a consulting or wealth management context, we want to maximize the efficiency of the capital. We aren't just looking for the highest return, we are solving for the highest return per unit of risk. By calculating the tangency portfolio, we identify the specific weights where our assets provide the most bang for our buck, relative to the 5% risk free rate I've set in the constraints bar. This, of course, could change, and I'm staying on the higher side of the standard. The output consists of the composition, efficient frontier, asset map, and the detail table. I use the historical average return method. The engine calculates the geometric mean of daily returns over the last year and analyzes it. However, it is vital to acknowledge the limitations. Historical data is backward looking. For example, a stock like TSM might have a high return due to a specific semiconductor cycle that may not repeat next year. In a fintech environment, we would typically supplement this with a forward looking analyst consensus or a black letterman model to avoid the pitfalls of assuming the future will be will perfectly mimic the past. Let me change the max weight constraint to 100% and then let's optimize and see what the asset does for us. Okay, so now we can see initially with the 100% max weight, the optimizer is greedy. It wants to put nearly 80% of our money into Google or Netflix if they outperformed. While mathematically optimal, this creates massive concentration risk. While I slide the max weight constraint to 20% where it was earlier, we can watch the bars for Apple and Microsoft rise as the capital is redistributed, as we just saw just before this. The trade off here is that my Sharpe ratio drops and my expected return might decrease. However, we have also improved our diversification. This is a classic consulting decision, sacrificing theoretical perfection for a robust, resilient portfolio that can survive a single sector crash. As you can see here, it takes time to calculate it, but since we just saw it, I don't think there's the need to wait for this. So, what does the efficient frontier show? So, what does the efficient frontier show? It's the cornerstone of the modern portfolio theory. On this chart, the x-axis represents volatility risk, and the y-axis represents expected return. Each dot you see is a unique combination of our nine assets: Apple, TSM, and the others weighted differently. Notice the bullet shape of the distribution. In finance, we call the area below the top curve suboptimal. Why? Because if for any point inside the cluster, there is a point directly above it on the frontier that offers a higher return for the exact same amount of risk. In consulting, we refer to this as dominance. A rational investor will always choose a dominant portfolio on the frontier over an inferior one. At the very nose of the curve is the global minimum variance of the GMV portfolio. This is mathematically the safest combination of our stocks. It isn't trying to make us rich, it's trying to keep the ride as smooth as possible. For a conservative client, perhaps a pension fund, this is where we would look. Now, look at this chart. This is our max Sharpe portfolio. In fintech, we view this as the Tangency portfolio. If you imagine a line starting from our 5% risk free rate on the y axis and drawing it so it kisses our curve, it would hit right here. This is the capital allocation line. It represents the best possible reward to variability ratio available to us. Ultimately, where an investor sits on this line is a question of risk tolerance. An aggressive investor would move to the far right. They're willing to accept the high volatility of Tesla in exchange for that vertical climb in returns. A balanced investors would stay near the center, using the stability of Microsoft or Apple to anchor the portfolio. By visualizing the frontier, we move the conversation away from which stock should I buy to what is the optimal risk profile for my goals. This is the shift from the retail trading to the professional asset management lens. To conclude, this project wasn't just about writing code, it was about building a decision support system. By following the driver methodology, from defining the investor's problem to reflecting on the limitations of historical data, I've created a tool that provides actionable financial insights. I've documented the full technical stack and the matrix logic in my driver report, and I've included the video transcript in line as requested. This project represents my commitment to the intersection of finance and technology as I prepare for my 2027 start in the industry. Thank you for your time.